Hello all, this is a video abstract of the paper titled Hybrid Attack Optimization Supported Enhanced Deep Learning for Facilitating Power System Event Detection Using PMU Data, paper ID 9199. The motivation for this research came from the fact that the phasor measurement units, that is the PMUs, provide bulk data to power system control centers, enabling essential functions such as analysis, control, and regulation. The data generated by these PMUs is of substantial magnitude, classifying it as a big data. However, this voluminous data cannot be directly utilized due to its sheer size. To harness the valuable insights within the vast PMU data, it is imperative to employ advanced processing techniques. This involves the application of appropriate algorithms to pre-process the data before integrating it into the main algorithm. So by developing and implementing efficient algorithms for processing the PMU data, we aim to enhance the overall performance of the power system control center. This research therefore seeks to optimize the utilization of PMU data, ensuring its effective integration into the decision-making process. The challenge lies in unlocking the full potential of the PMU data. Our research addresses the complexities associated with realizing the value of embedded in the extensive datasets, contributing to a more resilient and responsive power system. So we can summarize it as this research endeavors to overcome the hurdles posed by the enormity of the PMU data through innovative algorithmic solutions, paving the way for a more efficient, reliable, and responsive power system control center. Thus, there are two problems that are addressed in this research. First being to explore and identify an appropriate algorithm for the initial stage of event detection in power system. By delving into the intricacies of event detection, our goal is to enhance the efficiency and accuracy of the detection process, laying a foundation for robust decision making within power system control centers. The main contribution of this paper is to present an efficient pre-processing methodology for identifying unwanted, incorrect, missing, or noisy PMU data to facilitate robust event detection algorithm. So the first thing that we have used is the SMOT technique, which is the synthetic minority oversampling technique. This is used to balance the unbalanced data set. In the present data set, it contains minimum number of unbalanced data. So this kind of technique is used. The proposed methodology leverages real-time data-driven deep learning techniques for authenticating incoming data. This research proposes a deep learning approach that utilizes modified deep convolution neural network and long short-term memory classifiers to classify and extract the features from the PMU data, enabling high efficient detection of disturbances in the transmission line. Additionally, a hybrid attack optimization technique is used to enhance the convergence rates, accuracy, and efficiency. The performance evaluation of the proposed system is conducted by calculating and assessing disturbances generated by the power line by using various matrices such as the accuracy, precision, F1 score, system average interruption duration index called as psi-d, and system average interruption frequency index called as psi-p. Having developed the methodology, it is then tested on the mentioned performance parameters and then compared with other existing methods and found to be much better. So the accuracy is the first parameter. The percentage accuracy is found out to be 98.47% on a training percentage of 80 for the HAO, DCNN, LSTM when compared with KNN, SVM, random forest ANN and the other methods. Similarly, for precision also is on the higher side of almost 98.29% on an 80% training percentage compared to the other methods which are compared. Same is for recall percentage is almost 98.65. psi-d is found out to be almost 2 when compared with the other methods which are less than 2, and psi-p is found out to be almost 1, whereas other methods are much lower than 1 in this case. This slide basically gives a comparative analysis based on the k-fold method. So you can see in this table also that HAO, DCN and LSTM has a accuracy of almost 97.36%, which is much better than all other methods. Again, precision 98.69%, which is superior to the other method. Same way, 97.84 is the F1 score, SAIDI and SAIFI being 1.92 and 1 respectively. So in conclusion, this paper proposed a deep learning approach for event detection in PMU data, specifically focusing on handling unbalanced and missed data. To address the issue of unbalanced data, the SMOTE function was employed to achieve data balance by generating synthetic samples. This helped improve the precision of the event detection for unbalanced dataset by separating labels and features from the dataset. Then the proposed method utilized deep convolution neural networks and long short-term memory to effectively detect and classify events in the power system. The hybrid attack optimization technique was introduced to enhance the performance of the deep learning model in event detection by tuning the parameters of the modified deep CNN LSTM classifier. The HAO, DCN and LSTM approach demonstrated high efficiency, accuracy, fast response, and a low cost equipment implementation. It achieved a highly accurate detection of the events with accuracy, precision, recall, SAIDI and SAIFI values of 98.47%, 98.29%, 99%, 1 and 2 respectively. At the 100 iteration, the suggested solution has the lowest runtime of 0.454 second when compared to the other existing approaches. The case study demonstrated the use of PMU data for power quality analysis in the 400 grid kV of Maharashtra. The analysis identified power failures, sags and swells, highlighting the significance of real-time monitoring and analysis for grid operators.